Recording in progress.
Okay, so when we differentiate the log functions, there are certain rules we need to follow. The first thing we need to know is the ln. It's in your calculator. There's a special button for log and there's a special button for ln. So ln is the natural log, which is the log to the base e. So if I got log to the base e, it's known as ln. And you know what e is. If I got log to the base e, like log to the base e, where e is a number, Euler number, that is ln. So that's the natural log. We need to remember a few things for of the log. If the base of the log is same as the number you are taking the log of, the answer is always going to be 1. For example, before we start differentiation, let's have a look at a few things. If I got log 5 to the 5, the answer is 1. If these two numbers match, the answer is 1. If I got log 7, the answer is 1. Yeah? Log a to the base a is 1. So this is a rule. That's always going to be 1. If you're not putting the base here, it means we are considering the log to the base 10. One other thing, if I got ln of e is actually a 1 as well, because ln is actually a log to the base e with an e. So because they both are same, so answer is 1. So let me just clear this bit. And we come back to that one. Okay. Now, how do we differentiate? How do we differentiate the logs? Let's say I go y equals to ln x. When I differentiate that one, let's say y equals ln of a box. In box, there can be anything. Okay, so I want to differentiate it. So if I differentiate that one, the rule says differentiate with respect to x. If I want to differentiate that one, dy over dx equals d over dx of ln of a box. So in the box, there is, it can be anything. Now, the rule says it's 1 over the box and then differential of the box. This is the rule you need to know. I call this one as box rule. So this is the rule you need to know and quite important. Now we will do some examples. And we will see if that actually works. Now let's say if I got y equals to ln of x. So in the box is an x. So I want to differentiate it. dy over dx equals to, I said 1 over the box and d over dx of the box. So box is this bit. This bit is the box. So 1 over the x and then d over dx of the x. And I know d over dx of the x is just a 1. So answer is just 1 over x. Yeah. Okay, happy with that? Any confusion so far? Now let me do another one. Let's say I got another one. Y equals to ln of x cubed plus a 7x squared plus 3. And I want to differentiate this bit. Now, when I differentiate that one, that will become dy over dx, and that will be 1 over the box, x cubed plus a 7x squared plus a 3. Then I also need to do d over dx of the x cubed plus a 7x squared plus a 3. Now that thing as it is, I cannot change that bit because this is, I don't have to do any operation on that one. But when I do this one, what's the differential of x cubed? Anyone? 3x squared. What's the differential of 7x squared?
14x1.
Thank you, 14x1. You can write 14x1, still you get same marks, or if you write 14x, still the same. What's the differential of 3? 0. We can't differentiate the constant. So I can write this way, or I can write this way. Let's write this one down. X cubed plus a 7x squared plus 3, 3x squared plus a 14x. That's it. There you go.
Recording in progress.
Okay, so I got y equals to ln 3x4 plus 7 to the power 5. According to the rule of log, it says this 5 can come out. If you want, you can check that bit. If I got the ln to the 5 to the power 2, it's going to be same as 2 ln 5. If you put that value in calculator, you will get an answer. If you put that value in calculator, you will get an answer. Both of the answers will be same. Yeah, the answers, so they are exactly same thing. It's the way of writing it down. So now I got this one. Now I need to differentiate it. Differentiate with respect to x because there's an x, and this is my box. This is my box. So when I differentiate it, I will get dy over dx equals to d over dx of ln 3x4 plus 7. Now where is that 5 gone? Okay, here's the 5. Yeah, I just keep the 5 off. Okay. Now ignore the 5 for a minute. Focus on that bit. And you know what the box is. This is the box. So put the 5 there. And you know this dot mean multiply. 1 over the box. 3x4 plus 7. Yes. If I want, I can put brackets. Okay. Now another dot. Now you need to differentiate the box as well. According to this rule, we have to differentiate the box. So I have 1 over the box and d over dx of the box. So d over dx of the box. Now the box is 3x4 plus a 7. Okay. So this 5 on its own, this will be this 1 over 3x4 plus 7 here. Now this bit, I want to differentiate 3x4. So what's the differential of 3x4?
12x.
Yeah, yeah, good, good. So 3 is here, you did that one, yeah? So you did straight away. Yeah, that's what you did, yeah? 12. And what's the differentiation of 7?
0.
Okay, I still put 0. Yeah? Okay. Now let's have a look. This is 5. Instead of writing 5, can I also write that one as 5 over 1? Same thing, yeah? This is whatever it is. Can I divide that by 1? Same thing, yeah? Then I multiply that 5, 1, and all these bits and the bottom in together. So I will get an easy answer. So if I multiply 1 by times by this time that would be just still 3x4 plus a 7. Now multiply the top one. This is 5 times 1 is 5, yeah? And then 0 disappear, that 0 disappear. This is a 12. 12 times 5 is how much? 70? 60. Okay, yeah? So 60x cubed. This is your answer, dy over dx.
Recording in progress.
Okay, when you do that on the board, let's say differentiate. So I'm not writing differentiate with respect to x, but let's say dy over dx. Oh, sorry, I can't do that. I need to do one step. I need to do one step first. I need to write down y equals the 3. The 3 comes out. ln 4x7 plus 8x. Okay, so this 3 is being multiplied. Now, the next bit I'm going to do is differentiate. Differentiate with respect to x. So that will become a dy over dx equals the 3 is here and d over dx of the ln 4x7 plus 8x. Now, where is the 3 gone? The 3 is here. Okay. Now, when I got this bit, I need to do that one. 3 is here. Now, 1 over the box. 1 over the box. The box is 4x7 plus 8x. Sorry, let me write x. So this is my box. And the rule is 1 over the box and the differential of the box. The rule is here. Okay. Now, I need to differentiate the box. So differentiate the box. The box is just a 4x7 plus 8x. Okay, let's have a look. Let's do that one. Okay, 3 times 1 is just a 3. So I can write that one 3. 3 over 4x7 plus 8x. Okay, now when I differentiate this thing, 4x7, the 4x7 becomes 4 is here. x7 when I differentiate, that becomes, oh sorry, not 6. That becomes a 7x6. 8x differential is just a 8. So that's 4 times. Guys at the end. Okay, the 4 times the 7. That what's the 4 times the 7?
28.
28 x6 plus 8. Okay, now if you can multiply that bit, move the camera a little bit down. Okay, if you multiply that by 3, so 3 times that is how much?
84.
Thank you. 84 x6. 3 times 8 is 24. No x. Yeah. So I did that times this and this times that. Divided by, I got 4x7 plus 8x. You can do one last step. You can divide everything by 4 because you can see the 4 is here. Everything you can do divide by 4, which makes your life easy. Yeah. So that will become a 21 x6 plus 6 divided by 1x7 plus a 2x. This is your answer. This is your dy over dx. Yeah?
Do you have to simplify?
Yes, yes. We have to simplify. Okay. Now let's say I got this one and I want to differentiate it. Now there's a one bit here and there's another bit here and they are dividing. The rule for the log is when it's dividing, the log is dividing, we need to subtract them. So that will become ln 1 minus 3x minus ln 1 plus 7x. Yeah. So I got now two terms. This is my first, one term and this is my another term. Now I need to differentiate these ones. So now I'm going to differentiate it. When I differentiate, I put dy over dx, and I need to differentiate that one separate. So I'm going to put d over dx of ln 1 minus 3x minus d over dx of ln 1 plus 7x. So I'm going to differentiate that one separate and that one separate. So this one separate, this one. Now, according to the rule, you know how to differentiate this bit. Differential of that one is 1 over the box. The box is this bit is the box. 1 over the box, which is 1 minus 3x. And then differential of the box. Let's do that one first, and then we just move on. And if I do this one, this becomes a 1 over 1 minus 3x. And this thing, differential of 1 minus 3, differential of 1 is a 0. Differential of minus 3x is a minus 3. Yeah? If that was minus 20, if 1 minus 20x, it will be minus 20. So that's that one done. Now I need to do this part. So this minus is still here. Okay, so this is the box. We have a box rule. 1 over the box, 1 plus 7x. And then differential of this thing. And differential of 1 plus 7x is how much?
7.
Just 7. Okay. Now, let's simplify that one. So that will become 1 times minus 3. 1 times minus 3 is minus 3 over 1 minus 3x. So 1 times minus 3 is minus 3. They're not subtracting, they are multiplying. You can see the bracket. 1 minus 3 is 1 times minus 3 is minus 3, and that thing as it is. Yeah. This minus remains here. 1 times 7 is just a 7, and 1 plus 7x. Yeah. So there is a relation. You can do right that bit as it is. You can simplify it further. You can simplify it further into one fraction. Now to do that one, this is what you need to do. Simplify further into one fraction. Let's play X factor. Okay. Whatever is at the bottom, write it down. 1 minus 3x and 1 plus 7x. Write it down. Yeah. Then whatever this sign is, put that sign. Whatever this sign is, just put this one there. Whatever this was, minus 3, put it here. And that minus 7, just put it here. Yeah. Then what you need to do is cross multiply. This thing put here. This thing put here. 1 plus 7x. This thing put here. This thing goes here. Cross multiply. Don't need to do anything with the bottom one. The bottom one leave as it is. The top one, let's do the top one. Minus 3 times 1 is minus 3. Minus 3 times by plus 7. So 3 times 7 is 21. And minus 21. When the signs are opposite, the answer is a negative. Minus 3, if you put that minus 3 times plus 7 in calculator, the answer will be minus 2. And x is there. Okay, now next one. Minus 7 times 1 is minus 7. Minus 7 times minus 3 is a positive 21. X, thank you. Okay. Okay, now this is a minus 21 and this is plus 21. That cancel. And I got minus 3, minus 7. Minus 3 minus 7 is minus 10. I took £7 from you, then I took £3 from you. I owe you £10. So I'm in a negative. Negative £10, yeah? Okay, now I got y equals to sine. So y equals to x to the sine, x power sine x. Now, because there is, both of them are variables, there is no constant, so I cannot use the normal constant. The power comes out, use the power by 1, and so on, just like we differentiate y equals to x cubed, which is 3x squared, but I cannot use that thing here. So to do that one, to start with, I will take logs on both sides. First thing is, I will take log ln, which is a log, on bs. Now bs means both sides, yeah? It doesn't mean something else, so bs. Now let's have a look. ln y equals to ln x to the power sine x. Yeah. We have a rule. We have a rule. The rule states that ln x, if I got the ln, let me do that one here. If I got the ln x squared, the power, it becomes 2 ln x. The power comes here. Now here, this is the power. This thing is the power. Yeah, the power comes at the front. So that would become a sine x, ln x. And on this side, I have ln y. So on this side, I got ln y. Okay. Now what I need to do is, I need to differentiate both sides with respect to, yeah. What you thinking?
Oh no, I was asking what BS stands for.
BS. No, it's not British standards, yeah?
Bullshit.
Yeah. Okay. So what I need to do is, I need to differentiate both sides by x. So let's differentiate. So differentiate with respect to x on, again, this ds, yeah? Okay. So I need to do is, when I differentiate this bit, I need to do d over dx of ln y, and I need to do d over dx of the whole bit, sine x dot ln x, and I'm just going to put this thing in bracket like that. Yeah. Okay. If you remember, what was the, if that was ln x, we have a rule. We have a rule to differentiate that one. And the rule was 1 over x, yeah, but it's a y, yeah, and d over dx of the x, but it's a y, yeah. Yeah, so I got that one. 1 over y, dy over dx. This is differential of that bit, yeah. I got that bit. Now here, this is a product rule. There are two things, sine x and ln x. So it's like a product rule. So I need to actually treat it as a product, and then I will come back and do that one. So let's do the product rule here, and then we see. Okay, so here you go. I'm going to say, I will do here. U equals to sine x. So what will be du over dx? Differential of the sine x with cos x, yeah? Yep.
Yeah.
But now I go v equals to ln x. Differential of the v, or sorry, differential of the ln x is just a 1 over x. Yeah. Now a product rule. There's a video on the product rule. You can watch that one, but I will put the link there. Product rule says if I got d over dx of the uv is equal to u, then a dv over dx plus a v and du over dx. No specific order. You can put that one here, that one there, doesn't it? Now, if I put that one, what will actually happen? What will actually happen? What's the u? What's the value of the u? I don't know, so I'll go here, sine x. So instead of that one, I just put a sine x. What's the dv over dx? It's that bit, yeah? dv over dx is this bit. So it's like now I'm playing kind of x factor. That thing, yeah? They go together. So sine x and 1 over x. Plus, what is v? What is v? V is this thing. ln x. So I put ln x. And what is du over dx? Du over dx is this thing. Cos x. So differential of this bit is that whole thing. Yeah. Let me simplify here and then I'll write it much easier. Yeah. So we got sine x over x plus ln x cos x. That's it. So this is your differential of this bit is that. So I'm going to write this one down here. Sine x over x plus ln x over cos x. Okay. What was the question? Question was find the dy over dx. I still haven't found the dy over dx. On this side, there's one thing that is not required. It's 1 over y. This 1 over y, I don't need this 1 over y. So if I move the 1 over y on the other side, the y is dividing. On other side, it will multiply. So that becomes, oh, sorry, I use blue color. Blue, and then the other one is black. Okay, so I bring this y on the other side, and y is down on the, when you cross the equals line, it just becomes opposite. Sine x over x plus ln x dot a cos x. Okay. Now on this side, I have dy over dx. So on this side, I have dy over dx. Anyone knows what y is? What's y? Y is this bit. So I just copy this thing from here, y, and I just put instead of this y. So I got x sine x. Yeah, I put bracket. If you want, you can. And this one as it is. Sine x over x. Up to you if you want to put bracket here or not. ln x cos x. Yeah, that's it. You can further simplify, but I want to just multiplying that thing inside. It is in the simplified form. That's it.